Hey guys, Mr. Middleton here. Today we are going to talk about parallel lines. So at the end of this video, you should be able to identify parallel lines from their equations, and you should be able to write the equation of a line when given information about a parallel line. We're going to start off by graphing, so something we already know how to do. You see, we'll get to review some standard form and slope-intercept form in the process. So we have two lines. We have y equals negative 3/4 x plus 6, and we also have 6x plus 8y equals 16. So we're going to graph these lines. This first one in this pen. Actually, I won't. I'll do the first one in blue. There's no math with that. Okay, so this is in slope-intercept form, so I can graph that right now. My y-intercept is 6, so I'll go up 1, 2, 3, 4, 5, 6. My slope is negative 3/4. Okay, I'm going to move this negative to the top to help myself out. It tells me to go down 3, 1, 2, 3, and over 4, 1, 2, 3, 4. Okay. 1, 2, 3, 4. Not really a lot of space. Okay. So here's my line. Should go through these 2 points. Maybe. Alright, there we go. So there we go, my first line. Right there. Okay. And now I'm going to graph the second equation on the same line. On the same graph. I have 6x plus 8y equals 16. It'd be really nice if I could just use the intercepts, but I can't because 6 does not evenly divide into 16, so I know that intercept won't be a perfect number. I mean a whole number. So I'm going to change this to slope-intercept form. So I'm going to subtract 6x from both sides. Leaves me with 8y equals negative 6x plus 16. And then I'll divide by 8 to get y all the way by itself. I'll write my answer up here. And that will give me y equals negative 6/8 x plus 16 over 6. Sorry, 16 over 8. Simplifying that, I'll get y equals negative 3/4 x plus 2. So this equation in slope-intercept form. And now I'm going to graph this in slope-intercept form. So plus 2, my y-intercept. Negative 3/4 means I go down 1, 2, 3 over 1, 2, 3, 4. Okay. I could try to do that again, it won't work. I could also go up 1, 2, 3, and left 1, 2, 3, 4. Okay. And here is my line. There. Alright. Hopefully that works out for me if that's straight. Alright. So here are my two lines, and I just used them in different colors so you can see what they are if you're looking back or freezing it, which I know none of you guys do. Alright. So now look at these questions that follow along. It says, what do the two lines have in common? What do these two lines have in common? If we look at their equations, we should notice that they both have a slope of negative 3/4. They have the same slope. Negative 3/4. What's different about these two lines? Again, looking at the equation, we can tell what's different about the two lines. In our first line, our y-intercept is 6. In our second line, our y-intercept is 2. Y-intercepts. Okay. So summarize the characteristics of parallel lines. These two lines are parallel. Okay. They will never intersect. Never intersect, they'll never touch. Okay, we can tell that visually just looking at them. They are going their own way, and they'll continue on without ever getting closer or further away from each other. Okay, parallel lines have the same slope and different y-intercepts. That's how we can tell parallel lines. So now these next few questions are asking us to determine whether the given lines are parallel or not. And so the things that are important for us are slope and y-intercept. So I would recommend using slope-intercept form. Okay, I'm going to find my number 1. I have number 1. I have the slope of that first equation is 2. The y-intercept of the first equation is negative 1. And typically how these problems are going to work out is they're going to give you one of the equations in slope-intercept form, so you can easily identify those things. And the other equation you're going to have to do a little bit more work to it. Okay, so notice that we don't know the slope to this equation yet. Even though 2 is by x, we will only be able to find the slope once we put it into slope-intercept form. And that means getting y by itself. So in order to get y by itself, I'm going to subtract 2x from both sides. And that will give me y equals negative 2x plus 3. So identifying the slope and y-intercept of this line, my slope is negative 2, my y-intercept is 3. Are these parallel? No. Okay, these are not parallel because slopes are different. Parallel lines have the same slope. Okay, we see in number 2, the second one's already laid out for us. Our slope is 5/2, our y-intercept is negative 4. Okay. This problem, equation 5x minus 2y equals 8, is not in slope-intercept form, so we can't identify the slope or the intercept yet. So we're going to put it there in slope-intercept form. Subtract 2x from both, or 5x from both sides. Negative 5x plus 8, and then divide by negative 2. And once we do that, we'll get y equals negative divided by negative becomes positive 5/2 x. Positive divided by negative is negative. Okay. All right. So we find out that our slope is 5/2, and our y-intercept is negative 4. Are these two lines parallel? You might jump to the conclusion and say yes, because they have the same slope. But remember, there's two things we have to worry about with parallel lines. They have to have the same slope and different y-intercepts. These have the same y-intercept, same slope. These are the same line. No, same line. Okay, and so we'll go on to the last example here. In this last example, we see our slope for this second line is negative 4/3. Our y-intercept is negative 5. Okay, and now we're going to solve this and solve this for y, so we can put it in slope-intercept form to find out if these two lines are parallel or not. So if we do that, I'm going to subtract 8x from both sides, and that leaves me with 6y equals negative 8x plus 30. Okay, and then I'll divide both sides by 6, and that gives me y equals negative 8 over 6x plus 5. Okay, and I'm going to simplify this. You always want to simplify your fractions, and that gives me negative 4/3 x plus 5. Alright, so y is by itself. That means this is in slope-intercept form. And so we can find the slope. Our slope is negative 4/3. Our intercept is 5. Are these parallel? Yes. These are parallel because our slopes are the same, negative 4/3, and our y-intercepts are different, 5 and negative 5. Okay? Alright. Some other types of questions you'll get concerning parallel lines is you'll often be asked to write the equation of a line parallel to another line through a given point. When given those, we have a process. We're going to find the slope of the first line. Find the slope of the first line, because if we're going to write a line, the equation of a line parallel to the first line, we need to have the same slope. So if we look at this first equation, y equals negative 3x plus 4, this is in slope-intercept form, so we just have to identify the slope, and that means the slope is negative 3. Okay. Then we have to think about what's the slope of the second line going to be? Or find the slope of the second line. Say second line. And so, since this is parallel means same slope, we know that's going to be the same, -3. And then we're going to find the y-intercept using the point. Okay, so from here, we're going to say, okay, well, we're going to use this point, 7, -2, and then everything from here should be what we've already done in the last couple of sections of writing the equation of a line using a point and slope. So I'm going to plug it into slope-intercept form, y equals mx plus b, right, and plug in what I know. I know that y is -2. I know that m is -3. I know that x is 7 plus b. And now I'm going to solve this. So -2 equals -21 plus b. I will add 21 to both sides. And so that's 19. B is 19. My y-intercept is 19. My slope is -3 for a line going through the point 7, -2. And so I can write my equation. My equation will be y equals -3 x plus 19. All right, on the back side, I will go through the first step with you, and I want you to come to class with the rest of it completed. For this problem, it's a little bit another level of complexity in the sense that they did not give us the slope first. Okay, they want us to write the equation of a line parallel to 2x minus 4y equals 11. And parallel means it's going to have the same slope, but they didn't give us the slope. So we need to find it. And so what we'll do, we need to get y by itself. I'm going to subtract 2x from both sides. That leaves me with, I'm going to start over here, -4y equals -2x plus 11. Okay. Now to get y all the way by itself, I'll divide by -4. Y equals -2 divided by -4. That'll give us +1/2 x. And this is, I'll just leave it as a fraction because it really doesn't matter what it is. Because the important thing, the thing that we're searching for, is the slope. We know the slope of our first line is 1/2. And since we're talking about parallel lines, we'll have the same slope, which will be 1/2. We know the point that we're going to go through is 6, 1. Okay, so you guys please bring in the equation of the line going through this point. Okay, another way that we can do these types of problems is given a graph. Okay, we've done this before, and the steps remain the same. Find the slope of the original line, find the slope of your second line, find the y-intercept using a point. So the slope of our first line, see this point here, so I can go down to -2 is my rise, over 1, 2, 3, 3 is my run. So my slope for my first line is -2/3. I know that the slope of my second line will be the same because, again, they're asking me about parallel lines. Parallel lines have the same slope. So I need to know what point it goes through. Well, it goes through the point, this point, 1, 2, 3, 4, 5, 6, -6, 1, 2, 3, 4, 5, -5, -6, -5. Okay, and so let's write the equation of a line that has a slope of -2/3 and goes to the point -6/5, or -6, -5. So we'll start with the slope-intercept form. We'll plug in what we know. Slope is -2/3. The x-coordinate is -6. We do not know b yet. The y-coordinate of the point we know is -5. So -2 times -6, +12, divided by 3 is 4. Now to get b by itself, I'll subtract 4 from both sides, and that gives me -9. So I have the slope of my new line, I have the y-intercept of my new line, and so I have the equation of my new line. My equation will be y equals -2/3 x minus 9. No, why would I want to update this? Sorry, guys. So, just going through that really quick because I don't know when that popped up. We had our slope-intercept equation. We'll plug -6. Remember, this is our x-coordinate, this is our y-coordinate. Plug -6 in for x. Plug -5 in for y. Our slope is -2/3. Got that from this line. And then we just solved the equation out. Okay, solved it out for b. Once we found out that b is -9, and we already have our slope of -2/3, we can write it in the slope-intercept form here. Okay, remember to do this example for me. Bring it in. I will see you when I see you.